Yeah.
Are these new notes?
Yeah, these are brand new. These are brand new notes. So yeah, this is the headache edition, the headache-free edition. Sorry, what's up?
No, I said this is review or this is like a new topic?
No, it's review, but hopefully we're gonna do like a geometry problem first, and then we're gonna see if we can apply calculus to it. Okay. If you, yeah, because some of you are not critically thinking about like how the volume works. Don't worry. Look, you'll see right now. Do you remember? Oh, can you guys close it up? All right. Sorry, miss. Do you remember volume of a cone? What is it?
4 pi squared h.
1/3 pi r squared h?
4/3 pi r cubed.
Sphere.
Do we need to memorize that? Yeah.
Well, I mean, we should know, but I think they'll probably tell you common, like, little formulas. You know what I mean? All right. In geometry, if they told you that the radius was 3 and the height was 6, you would find it just by plugging in. You would find the volume just by plugging in 3 squared times 6. One of these 3's cancels out with one of those. And then you just get 6 times 3, which is 18. So 18 pi. And that's my volume. Yes or no? Okay. If I were to turn this cone on its side and use calculus, so here's my grid. And I have something like this. And I want this height to be 6. And I want this to be a 3. So then this equation will be 1/2 x. 1/2 6 is 3. Yep, there it is. Are we okay? Haven't done anything crazy. And I'm going to rotate it on the x-axis. And if I rotate it on the x-axis, I will get the exact cone, which we already know what the volume is. The volume is 18 pi. And we're going to see if calculus verifies this for us. Of course, we're doing overkill, but okay. The whole thing is we need to find a common cross-section, because that's how you find volume. Integrate from A to B of a common cross-section. What's the idea?
Integrate A to B of a common cross-section.
Yes, because the idea is this. Look, here's the idea right here. If you have a sheet of paper, do you agree that this sheet of paper is practically volumeless? Like it's practically volume is 0 practically? But it does have an area. See this cross-section area? And I know you wouldn't need calculus for this because all of them have the same shape over and over. You just use geometry. Look, here's an infinite amount of cross-section added together. And now look, it has this depth. So now it creates volume. And that's the idea. We find a common cross-section and we integrate an infinite amount of them and add them all up and it creates volume. Does that make sense? So check it out. That was a good one, miss. So,
But A of x is the area.
A of x is area, my common cross-section area. There is my common cross-section. What shape is that? What? It's a circle.
I wasn't looking at what you were saying.
You could also say disk. So how do I find area of a disk or a circle? Yeah, pi r squared. All right, here we go. Volume equals pi on the outside because it's a constant. Integrate. I'm going to integrate from what x value to what x value. And underneath the radius is the distance from the x-axis to that curve, which is what? Perfect. Dx. I'm going to square. You don't have a calculator. So pi integral 0 to 6. X times x is x squared. 2 times 2 is 4. I can do this. We can do this without a calculator. Pi on the outside. And I guess I could have factored out the 4 there, but no big deal. X to the third power over 4 times 3 is 12. And I'm going to factor out the 12. Antiderivative? No, you're good, miss. You're good. Pi over 12, bracket 6 to the third, close it. Some of you may know what 6 times 6 times 6 is. I just kind of just do this. Pi over 12, 6 times 6 times 6. It's a product. And yeah, I would. Yeah, probably. Here's what I do.
Oh, wait.
Look. Look how simple this is. You guys are making it hard. How many times does 6 go into 12? 2. 6 times 6 is 36. I can divide 36 by 2 real quick. And look, what's the pi? That. 18 pi, 18 pi. Give me a radius, a nice number. 2? 4? In between 2 and 4. 3.
3, yeah.
All right. Yeah, but one more time. Volume of a sphere. Do you guys remember? Par cubed. So here's my sphere with a radius of 3. So 4/3 pi times 3 cubed. One of these 3's cancels out again. You can see why I like 3 so much. 3 squared is 9. 9 times 4 is 36 pi. All right. With calculus, how would I do it with calculus? Here's my grid. And I'm going to put a circle or semicircle. And that's 3, negative 3. We'll get the equation of that right now. That would be like x squared plus y squared equals r squared, so 9. Are we still okay? And if I rotate this semicircle around the x-axis, wouldn't that be a sphere? And if I do a cross-section like this, it would be a disk. And I can do 2 things. I can integrate from negative 3 to 3. Or what would be the smarter way? I would integrate from 0 to 3, and then what do? Yeah, because the 0, I don't have to calculate another step. Does that make sense to you guys? So that's what I'm going to do. So here we go. Remember, I'm going to multiply by 2, and I better get that 36 pi. So I'm going to integrate. So pi on the outside, integral from 0 to 3. And by the way, what's the equation of that? Y equals square root of 9 minus x squared. And then the radius is the distance from the x-axis to that curve, the top curve. And that curve is this guy right here. Let me make sure that I got everything correct. Yeah, everything looks good to me. So square root of 9 minus x squared, close it squared, dx. It's pi r squared, no?
It's a disk.
Yeah.
Sorry, I was thinking it was square.
Yeah, no, that's how we did it with geometry. Is everyone okay with what I have so far?
Yeah.
When I square a square root, what happens to the square root? Cancels out. So here's what I have. Pi, integral 0 to 3. Now remember, we still have to double it. 9 minus x squared, but we're not going to do that to the very end. So pi, bracket, what's antiderivative of 9? 9x minus what's antiderivative of x squared? 0 to 3. I don't have to worry about the 0. So 3. 9 times 3? 27. And then 3 cubed over 3, so that's just 3 squared. So 27 minus 9. Yeah, look how beautiful this is. So 18 pi, but that's just half of your sphere. If you want to get the whole sphere, it is that match the same thing that we got? Okay. So do we understand the concept? Okay. Here is the major concept. I'll write it here on the side. Volume is equal to the integral from A to B of your area cross-section. That's the whole shebang. You find a common cross-section that retains its shape. It just changes by a scale factor. And you integrate it because you want to add up an infinite amount of cross-sections. Cool or not cool? Okay, let's see if we can do, we're going to do 2 free response questions. They're reruns. And then we're going to do, because I remember someone yelled yesterday, and I want different shapes. And there is my different shapes. All right. So here we go. 2005, calculator active. Do you guys have your calculator? All right. let f and g be functions given by, and they give it names. I'm going to type this into y1, the f, and I'm going to type g into y2. So 1/4 plus sine pi x. Let me see if I can remember that. 1/4 plus sine pi x. And then 4 to the what? 4 to the negative x. Was that it? Oh, wow. Okay. So there it is. I got it at y1 and y2. And let R be the region shaded in the first quadrant. Okay, whatever. I see all that. Let's see. Find area of R. Okay. So I need to find where those two intersect. Do you guys see that? So I take my calculator and I'm going to push window, and I don't care about the negative so much. I'm going to go negative 10. And for now I have it as 10 and y min negative 1, y max 10. Let's see how it looks initially. Oh yeah, I got to zoom in way much. All right, so window, let's zoom in. X max, make it 1.5 it looks like. And then y max, make it like 1.5 as well. Oh, force it to stop, push enter. And then push on to break it. And there it is. I mean, it's not the best, but it looks pretty good to me. And I want that intersection right there. So I'm going to go second, calculate number 5, enter, enter, and then go to the close one you want. It needs to say the word intersection. I got 0.178218. Is that what you got? Yeah. Save that to A, guys. So I'm going to save it. So here we go. I'm going to go to my home screen. I'm going to push X, the store alpha A, enter. There it is on A. Sometimes I push enter, sometimes I just go right into it. Today I just felt like going right into it. Cool. All right, here we go. Region R. So I'm going to go R is equal to integral from 0 to A. Oh, I already see an issue. Did I tell them what A was? No, and this is a calculator active, so this is probably going to be worth a point. All you do is say this. You just say 1/4 plus sine pi x equals 4 to the negative x. Do I got to show them any arithmetic on this? No. You just say, where are they equal? They are equal at, give me the 0.1782. Give me as many digits. 180487. And then I call this what? A. You can either put an arrow or your equal sign, equal A. And there it is. I got full credit now, and I go 0 to A. Now they see what A is. Cool? All right, and then what curve is on top for the region R? So I put G of X minus what curve is on bottom? F of X. Close, or you don't have to close it, but there it is, dx, and you just give me now the answer. So I'm going to go to my calculator, and hopefully I did everything correctly. Math 90 to A, and then alpha trace y2 minus alpha trace y1 at x, enter. I got 0.06475. Is that what you got? 0.06475. And that's it. Find the area of S. Okay, let's see where these two intersect. Excuse me. Oh, it looks like these two intersect at a perfect one. Calculus 5.
So it's 1.25. Well, no. The x is 1, the y is 0.25.
Okay, I don't care about the y. I just care about the 1 because I'm integrating with respect to x. But maybe I'll need that y value. All right, find the area of S. Area of S equals integral from A. Now that you used A before, now you can import it. All the way to 1. And what curve's on the top now? F of X minus G of X. And let's see what that is. 801. All right, 801. Second quit. Math 9. Alpha A to 1. Alpha trace y1 minus alpha trace y2. Yeah, make sure, guys, let's make sure that you sweat, guys, because You know, you're going to be doing these same skills with the calculator. Make sure you grab a calculator and give it out. 0.410. Are we good there, guys? All right. Let's go to the next letter. Here we go. We got a volume question now. As soon as you see a volume question, you're looking for a common cross section. Find the volume of the solid generated when S is revolved about the region -1. So I'm looking at this region specifically. And I'm rotating it about, I'm going to say -1's right here. -1. And let me see if I can draw this guy. I don't know if I'll be able to draw it perfect, which is fine. But a picture always helps, guys. Doesn't have to be perfect. Wow, that's actually probably one of my better pictures. Well, okay. I spoke too soon. It's fine. It's fine. Be careful. These are washers. These are washers. Yeah. See the hole? The gap? Do you see it or not?
So it's big R minus the little r.
Are you sure? Yeah. The shaded region is the solid part. And then there's like a...
I don't want to talk about it.
I did buy washers. All this is a hole. Like, yeah, like, I'll go. All this is a hole.
Big R minus the little r.
You see it? Because this is solid.
Alright, then I'm changing.
Okay. What is the common cross section? Guerrero, what's my common cross section?
Oh, wait. What do you mean?
What's my common cross section? What's my area? No. Look.
I'm confused what you mean.
Yeah, look, it's not a disc. This is the solid part, and you're rotating it around -1. All this right here is open.
Yeah, it's a disc.
No, this is open. It's a washer.
I was saying washer in my head, but it's coming out disc.
Oh.
I'm really bad at explaining.
No, yeah, you're good. You're good. As long as we know. So look, here it is. Here's the shape of a washer. And I'm going to call this big R. And I'm going to call this little r. As long as you know that you get an area for a washer by doing pi r squared minus pi little r squared. Notice you can factor out a pi. And you just get big R squared minus little r squared. That's what I'm going to integrate. Yay or nay? All those slices, are they dx's or dy's? Dx's. So everything's going to remain the same. So you're going to go pi on the outside, integral, from what to what? A to 1. You can import a because you use it on little a. So you can import a all you want. And then the big R. Yeah, you can go f of x minus -1 because I know I'm remembering now David Cruz. He would always yeah, you told us always upper minus lower. Which you can either say f of x minus a -1, close it squared, that's big R. Or I also remember telling you guys axis of rotation minus curve, and it will work. Yeah, -1 minus whatever you want. And we're not done yet, that's big R. Minus, what's little r? Well, it's this curve right here, g of x minus -1. So look, both of them will get the same answer. G of x minus a -1 squared dx. Or you can go axis of rotation minus a curve. -1 minus g of x. It does not matter which one you want. Which one do you like better, the one on the top or the one on the bottom? Top? Yeah. Okay. No one likes the one on the bottom? They're both the same to me. What I've found, I shouldn't say this because then you might be conflicted. But okay. I once had a kid who would get confused where he was a boy, and he'd be confused depending on where the axis of rotation was. Sometimes it was at the top, sometimes it was above the x-axis, sometimes below the x-axis. And the curve, the f of x would sometimes like cross the x-axis, and he would get confused because of the signs and whatever. And I told him, just go axis of rotation minus curve, and you'll get it right every time. And that helped him because he didn't have to think. He would just be like, axis of rotation minus curve every time, and because you're squaring it, so yeah, because since you're squaring it, you don't care about the negative's gonna go away. So if you're like, whoa, I don't know what to do, I don't know, axis of rotation minus curve, no thought involved, you just make it a habit.
Yeah, but now I'm gonna write this one down because I already know that.
As long as critical thinking's key.
Yeah.
Whatever you want to do that you know is true.
Yeah.
All right. I'm going to try both of them so you can see that both of them are true. And here we go. Pi, math, 9, alpha a to 1, open parenthesis, alpha trace y1 minus, I already forgot, minus -1. Close, squared, minus, open parenthesis, alpha trace y2 minus, comma, -1, close, squared, x. I got 4.55. Now check out the other way. If you just do curve minus whatever, pi, math 9, alpha a to 1, open parenthesis, -1 minus alpha trace y1, close squared. Yes, miss.
I think my calculator's tripping because I've looked over everything to make sure everything's in sync, right? But something's not adding up, and it keeps giving me 0.
Well, if it keeps giving you 0, that means you have something that's being multiplied by 0. Either a variable or
Oh, that's why. I figured out why.
why?
Because my x is equal to 1. So when I plug it in,
Yeah, see, so change your A. And don't use
I feel like
oh wait.
Okay,
I didn't mean if you don't use part of that's weird.
because you never do that.
I think I did, but you guys did like the second intersection.
And push enter them. Look, guys, here's the results. Notice it doesn't matter how you do it, you still get the same answer. Are we cool? All right. Are we getting better? All right. Let's go to the next one. All right. This one is no calculator.
Oh, me either.
4.558. Yeah, the more digits, the better.
I put a lot of digits because I get scared.
Oh, if it's okay, because sometimes you need a value like an intercept, and if you cut it too early, your integral is going to be off. Do you know what I mean? Okay. All right. This one right here, guys. If you have no calculator, they're testing to see if you know how to do the correct antiderivative. So let R be the region in the first quadrant enclosed by the graph 2x and x squared. Find area of R. Here it is. Hopefully you know which one's a parabola, which one's not. X squared and 2x. And you have no calculator on this one, guys. So integral from what to what? 0 to 2. What curve's on top? 2x minus what curve's on bottom? Close it, dx. That's probably worth a point just doing that. And now let's do the antiderivative. What's the antiderivative of 2x? What's the antiderivative of x squared? From 0 to 2. Good thing that the 0 is going to zero out everything, so I just got to worry about the 2. So 2 squared is 4, minus 2 cubed is 8. Can you leave it like that? 4 minus 8 over 3? Yes, you can. If you are prone to accidents, math accidents, leave it alone. I encourage you to keep going, but
I'll keep going, but a lot of the errors that I've had are alpha errors. So if I have enough time,
all right, next one, guys. So here's, this one's the one that got everyone. So let's see. Actually, did anyone get it right? One person, and everyone else got it wrong. Do this one right here, this letter. All right, this letter. Let's see if we learned anything today. The region R is the base of a solid for this solid. All right, guys, get it. At each x, the cross section perpendicular to the x-axis has an area of this. Find the volume of the solid. How do I get it?
I'm gonna say integral.
From what to what?
Pardon this interruption. This is a reminder that all of Mr. Vega's classes they will be meeting in the portable for the rest of the day. All of Mr. Vega's classes will report to the portable for the rest of the day at this time. Thank you.
From where? 0 to 2? Okay. They give you the cross section. Guys. Look, they tell you.
Like a of x minus this squared.
No, this is the cross section.
So then, okay.
You only square it if they tell you like you have a square. Remember, look. Okay, look. Let me go back to look what you're doing. You're only doing this. You remember a common cross section. They told you the common cross section.
The volume is just the integral of the area.
Yes, you're adding up all the areas, and that's how you get that depth.
Makes sense. Wait, I think it just.
Yeah, you're just finding the reason why you're like, oh, so you got to square it. That's because when we found a disk, it's pi r squared. You put a pi on the outside. If it's a square, then it's just side squared. If it's a rectangle and they tell you the height is related by 3 times the width, then you're finding the area. Mm-hmm. Once we integrate and we add them all up, that's the volume.
Area under the curve. So when you do the area under the curve of the area, it's all of them together.
Yeah, because it's 3-dimensional. You're adding all of them up. Yeah, I just thought of a problem that I need to hit you guys with. Like, let's say if you have a rectangle, how would I, like, a common cross-section of a rectangle? I'm going to do that next, maybe sometime next week. But yeah, look, they give you the cross-section, guys. So here we go. 0 to 2 of sine of pi over 2x. They're testing to see if you know how to do the antiderivative of that. What is the antiderivative of sine of pi over 2x?
It is negative 2 over pi cosine of pi over 2x.
Yeah, you're right. The derivative of cosine is negative sine, so yeah, you got it right. Now, how do I evaluate?
Factor out the negative 2 over 5.
I think it's easier to factor out the negative 2 over 5, so you're getting my habits. You don't have to. Some of you, there's at least 2 of you that leave the constant in there. That's fine. If that's your habit and you feel safe, you can go ahead and do it like that. Cosine of pi over 2 times 2 minus cosine of 0. You can actually leave it like that on this one. But on this one, for the most part, on all the other ones, I encourage you to. On this one, I agree with the professors on this one, because you should know if you're going to be an engineer or a medical doctor, you should be courageous. This one, the 2's cancel out. Cosine of pi. What's cosine of pi? Negative 1. What's cosine of 0? 1. Negative 1 minus 1? Negative 2. Negative 2 times a negative 2? 4 over pi.
Would we have, because this is no calculator, how many steps could we jump? Instead of putting cosine pi over 2 times 2, could you just immediately go from the antiderivative to cosine of pi?
Yeah. You can go right from here to cosine of pi minus cosine of 0. Yeah. Perfect. And if you don't know what cosine of pi is, then yeah, I do encourage you to leave it like cosine of pi, but you do know, so. Okay. Cool or not cool? All right, here we go. This one you're going to get correct, Estrada. Ready? This one, they want you to come up with the cross sections, guys. All right, go focus. This is the last one we're gonna do, and then the next time when we meet again today, we'll do the second half of this. Another solid has the same base R. For this solid, the cross section is perpendicular to what axis? The X or the Y? The Y. So do a horizontal line like this. That's a cross section, and that cross section, you have a little square coming out of it. I can't see like that. Yeah, because look, it says are squares. Right, but do not evaluate an integral expression for the volume of the solid. Here's what you ask yourself. Is this cross section a dx or a dy? It's a dy. Do you guys see how that's a dy? Yeah. And you're adding them all up, an infinite amount. So if you're going to integrate with respect to y, I need these equations in terms of x equals something with y on it. Does that make sense? This one was y equals 2x, and this one was y equals x squared. So here's how you do it. X equals, for this one here, I'm just going to divide by 2. So x equals y over 2. Cool or not cool? For the quadratic, y equals x squared, that one is x equals square root of y. So now here we go. Area, or no, volume, is equal to integral 0 to 4, my new limits, because I'm integrating with respect to y. And then it's the rightmost minus leftmost. What's my rightmost? So square root of y minus leftmost. Close it, and it's a square. How do I get area of a square? Square it, and then I put a... Do they want me to solve? They do not. You guys ready? All right, so question 3, it says, let's see, find the cross section. The solid lies between planes perpendicular to the x-axis, -1 and 1. The cross section perpendicular to the x-axis between these planes run from the semicircle y equals square root of -1, negative square root of 1 minus x squared, to the semicircle square root of 1 minus plus 1 minus x squared. Here's the x and y axis in a three-dimensional shape. They try to do it as best as they can. This that I'm highlighting in red is the positive one, y equals square root of 1 minus x squared. And this one that I'm highlighting in sky blue is the negative one, y equals negative square root of 1 minus x squared. And right now, all they want is for you to give them one cross section. And you can tell by looking at it that one of those cross sections coming out of the board, I guess, that's a semicircle there, and then I guess that's the other circle. So one of these sections is just a disc, a circle, perfect. So area of that circle is just nothing more than pi, and then the radius is the distance from the x-axis to the top of that curve, and the top of that curve is just going to be the square root of 1 minus x squared, or the distance of that curve, and I square it, and there it is. So a of x is pi, when you square a square root, it's just 1 minus x squared. Done. How do we feel? We feel okay? If you wanted the volume, you would just integrate from -1 to 1 of that. It's, by the way, this is also, the three-dimensional shape is a sphere with a radius of 1.
So then this is just like the area of that cross section.
Well, yeah, it's just, well, you're just finding the cross section. That's the directions of this. Don't worry, in the next question it's going to say, give me the volume of these, which all you do is you integrate this guy from -1 to 1. That's -1. Here's 1. All right, the cross sections are squares. So now the cross sections are squares. Remember, it's coming out of the board here, so you can see the squares coming out. And how do I find area of a square? Or a side squared, right? Okay, so I need the distance from, I need this distance that you see here in red. Well, I know half of that. The distance from the x-axis to the top of that curve is square root of 1 minus x squared. So you can think of it in two ways. You can either go parenthesis, square root of 1 minus x squared, and I know that covers half the distance, so I multiply this by 2. And then I square that. Or you can think of it as upper minus lower. The top curve is square root of 1 minus x squared minus, and then the bottom curve is a negative square root of 1 minus x squared. And this will give me the distance of one side, and then I square that. And it should be the same answer. You can think of it of both ways. Look, when you minus a negative, doesn't that cancel out? And then look, guys, 1 minus x squared plus square root of 1 minus x squared. Well, I have one of these and I got another one of those. What's 1 plus 1? So, 2, 1 minus x squared, close it, squared. And there it is. And make sure, yeah, no more yawning, guys. You guys are going to make me yawn. Make sure that you know we're not robots. Why are we squaring it? Because area of a square is side squared. So I'm literally just finding one side and I'm squaring it. Does that make sense, Guerrero?
Yes.
For sure.
Yes.
Faux show.
Which one?
Okay.
Which one do you like more?
It doesn't matter as long as you use logic. Some people like the distance between the x-axis and the top of that curve, since the top of that curve is square root of 1 minus x squared. Like, I know that. That's just that. So if it's symmetric, the other half must be that times 2. Some people like to say, well, let me do it in black here. The top of that curve is square root of 1 minus x squared. The bottom of that curve is negative square root of 1 minus x squared, y equals. So upper minus lower. Oh, there's 2 of them. Like, you know what I mean? 2 square root of 1 minus x squared. And then because this is a square and that side is the same as this side, square both sides. Or square. Yeah, just however you see it that you think is easier.
And as long as it makes sense.
Yeah, just correct. It's all logic. Math should be the easiest thing, right? Because it's all logic. All right, here we go. Now we're getting into good ones. Look at this one. The cross sections are squares, but this time the diagonals are in the XY section. So let me see if I can highlight one of these in black or in red. Yeah, but like Pythagorean theorem. Look, that diagonal, I'm going to draw it. So let me see if I can draw it in black, the side of the square, and I'm gonna do it in 2-dimensional right now. So do you guys see that square? Yeah. Okay, so here's that square, the 2-dimensional square. Man, I suck. Did I ever tell you I got a D in art?
Yes.
Yeah. There it is. I tried to color code it. The red is what's on the paper, on the XY grid, the 2-dimensional. And then the black, you have, imagine like here's, and then you have coming out, and then the pointy thing is right on, coming out of that board like that. Cool? All right, so how do I do it? Well, I know the distance for that in the red is 2 square root of 1 minus x squared. And I know, let's see, from geometry, I know that a square has these sides the same. Well, all of them, really. And so that means it's a 45, 45, 90 triangle. And in a 45, 45, 90 triangle, you have n square root of 2. You guys remember that?
Yes.
All right, perfect. So this right here, the 2 square root of 1 minus x squared, is for this guy, because that's hypotenuse. So I'm going to write n square root of 2 equals 2 square root of 1 minus x squared. And what you're trying to do is get one of the sides, so I'm going to get n by itself. So I'm going to divide both sides by square root of 2. Do you guys see what I'm doing? So I'm going to have n equals, and I guess for now I'm going to leave it like this. 2 square root of 1 minus x squared over square root of 2. You can rationalize it, but I'm going to leave it like that. This is for a reason. That's one of my sides. How do I get area of a square again? I square it. So I'm going to write a of x equals, and I'm going to type this in there, and I'm going to square it. 2 square root of 1 minus x squared over square root of 2 squared. Law of exponents. I'm going to go slow. Law of exponents. 2 times 2. 4, parenthesis, that's a square root. Square root times square root. Square root goes away. Are you guys okay with that?
Yeah.
And then square root of 2 times square root of 2. 2. What's 4 divided by 2? So this is just 2 parenthesis 1 minus x squared. So my a of x is 2 parenthesis 1 minus x squared. You can distribute the 2. 2 minus 2x squared if you want. Oh, I didn't even look at this. Maybe this would have helped us. The length of the square root diagonal is square root of 2 times the length of its side. Yeah, that would have helped. Well, it's the same. We got it. Length of the side times square root of 2. All right. Go to the next page. Oh, no. These are equilateral triangles. Okay, I'll stop. Equilateral triangles means all sides are the same. So notice, look, there it is. That triangle in red is this triangle. Did I say red? Man, I must be real tired. That triangle in black is this triangle in black. And let me see, what do I want to highlight? This sky blue is this sky blue. We okay?
Yeah.
All right. I need to figure out the height of this triangle. It's not drawn to scale, but if it was, now that I cut it like this is 30 degrees, this is 60 degrees, because it was all 60 degrees. You guys see that? This in sky blue is a distance of what? 2 square root of 1 minus x squared, because it's going from the top of one curve to the end of the other curve of that circle. Does that make sense, guys? Okay, so here we go. In a 30, 60, 90 triangle, 30, 60, 90 triangle, it's n square root of 3, and 2n. I need to figure out the height of this triangle, unless you remember, well, let's just do it like this, because I don't want to make it more complicated. So here we go. So the area of this triangle is 1/2 base, which is 2 square root of 1 minus x squared times height. So height in a 3690 triangle, I find my short leg and I multiply it by square root of 3. It's easy to find your short leg because the short leg is just half. So the short leg, I know it's supposed to be symmetrical, or it's supposed to be cut it right to the middle. Like this distance is supposed to be the same as this distance. But, I didn't draw mine perfect. I'm sorry. So short leg is just half. So square root of 1 minus x squared. And whatever that is, I multiply by what to get the height?
I'm kind of lost.
Okay. Where did I lose you?
Right when we started doing like the short leg, like
Yeah. Okay, so let me explain. 60 degrees, 30 degrees. This is the short leg. This is the long leg. And this is the hypotenuse. The hypotenuse has the same length, 2 square root of 1 minus x squared, because all sides are the same because it's an equilateral. And when I say short leg, I'm referencing just one of these triangles, like that. And this is supposed to be 30 degrees, so this guy down here in sky blue that I'm making it super dark, that's supposed to be my short leg, which is half of the 2 square root of 1 minus x squared, and half of that is just square root of 1 minus x squared, right? And then to get my long leg, it says here to get my long leg, I take my short leg and I multiply by the square root of 3. So I just took this value and I multiply by the square root of 3, so I'm going to go square root of 3 times square root of 1 minus x squared. And then I did, so what is all this that I have here? Area of a triangle is 1/2 base, which is all of this. Not to be confused, I know, because I keep talking about two different triangles. All of this is your base of this one big equilateral triangle times the height of that equilateral triangle. Base height divided by 2. But I don't know if you guys remember, and I'm kind of scared to even bring it up. Remember when you guys were in pre-cal, we talked about how we can find the area of any triangle. It doesn't matter how it looks. Like if I have this leg A and this leg B and this angle between A and B, I could find it by just going 1/2 AB sine C. You guys remember that?
yeah.
I could have done that, but I didn't know if you guys remembered that or not. And we would have gotten the same answer. We would have gotten, let's see, 1/2 this times this, which is the same thing, sine of 60. So watch. Well, first, yeah, I already started, so let me just start. 2 square root of 1 minus x squared times 2 square root of 1 minus x squared sine of 60. And sine of 60 is 1/2, right? Oh, actually, it's not. Sine of 60 is square root of 3 over 2. And so I would have 1/2. And then check it out. This and this, the square roots cancel each other out. 2 times 2 is 4. So I would have had 4, 1 minus x squared. And then times sine of 60, which is square root of 3 over 2. And let's see, we would have gotten the same thing. Half of 4 is 2. And this 2 and this 2 cancel out. And I would have square root of 3, 1 minus x squared. Okay, so supposedly that's my area formula. Let's see if this gives me the same thing as that. Let's see. 1/2 of 2 cancel out. And square root times square root, the square root goes away. And look, square root of 3, area equals, I'm using this top one up here, square root of 3 times 1 minus x squared. And we got the same thing as we would have gotten when we had pre-cal, AB sine C. Do you guys remember that?
Yes, I remember it.
You could have also Googled how to find area of any triangle, not just a right triangle. But whatever, it doesn't matter. That was kind of tough because you have to know a lot of geometry. A of x, so there it is, square root of 3, 1 minus x squared. I do want to do an area problem or volume problem where you have to find out, like when they give you the scale and you have to work with that. But I feel that our energy is kind of low. You know, I see a lot of you with your heads down. So we'll worry about that on Monday when we'll just do a real quick 10-minute snippet, and then we'll jump to whatever we got to do. All right, number 4. It says find the volume of 3b. So find the volume of 3b, whose bases were squares. Okay, so 3b here was the area cross section. Where are you? This guy. So I'm gonna go volume equals integral from -1 to 1. And then I'm just squaring this guy. 2 square root. Okay, so I'm going to go 2 square root of 1 minus x squared, close it squared, dx. Can we do this by hand? Yes, we can. Integral, -1 to 1. 2 squared is 4, and then square root times square root goes away. So 4, 1 minus x squared, close it dx. Because I have a product, I can actually move that 4 outside if I wanted to. You want to do that? You can. Yeah, whatever you think is easier. Do you guys think it's easier to distribute? It doesn't matter to me. Okay. It doesn't matter. Whatever you guys think is easier. Here's my 4 bracket, and then antiderivative of 1 is x. Antiderivative of x squared is x cubed over 3 from -1 to 1. And let's see, leave the 4 factored out. Big bracket here, 1 minus 1/3 in parentheses, minus parenthesis, -1 plus 1/3, close bracket. Close and then bracket again. So let's see what that is. 4 bracket, 1 minus 1/3, I think that's 2/3, minus -1 plus 1/3, I think that's -2/3, so minus a negative, so it turns to a plus. 2/3 plus 2/3, that's 4/3. 4 times 4, that's 16. So 16 over 3. Does someone want to check it with a calculator real quick? That if you type this in there, you get 16 over 3?
I've seen her handshake.
I also wanted actually.
No, I actually have steady hands though when I record video. Steady hands. I don't know if recording a video equates to like brain surgery. No, but okay, well I didn't say brain surgery. I said doctor. Yeah.
Oh, okay, I thought we were talking about surgery. I was supposed to check my pulse.
Yeah.
Check your
No,
pulse.
I mean, anybody, I was just like a general physician.
Oh, okay, yeah, okay.
If Alvarez was a financial advisor, I would trust her also.
We
A
did.
doctor.
I'm talking about Angie being a doctor.
A medical doctor?
Yeah.
I would trust her.
If I had to trust someone to be my neurosurgeon, it would be Sophia Ramirez. Absolutely. Because I know she'd be so serious about, well, obviously, yeah.
If Alvarez was a firefighter, I would trust you with my life.
I don't think she'd be able to take anyone out of the baby.
No, yeah, I believe you would get so buff.
Buff
in that moment.
Yeah, no,
Is that
like if you was a firefighter, she'd be so buff.
All right, last one, guys. Last one. Hang in there. One more. This is the last one. So give it everything you got for the last 5 minutes. So here we go. Pretend like everything was on the line on this one question. The solid lies between planes perpendicular to the x-axis at -1 and 1. The cross-section perpendicular to the x-axis are circular discs whose diameters run across from the parabola y equals x squared to the parabola y equals 2 minus x squared. So let me draw it in 2 dimensions. It's already there, and they tried to make it look 3-dimensional. Here's how it looks in 2-dimensional. And
Oh, I just gotta know it.
well, yeah, but remember, look, I know you're like, okay, I just gotta know it, but how? But how?
How do I visualize
Okay,
it, Charles?
look, how do I visualize it? You know how y equals x squared looks like.
Yeah.
Everyone, we all took algebra. 2 minus x squared is just x squared going down with a vertex on the y-axis at 0, 2. Yes or no?
Yeah.
So let's say, okay, I can't see it like that. All right, see it like this. And what's happening? Let's see it again. The cross-section perpendicular to the x-axis are circular discs. Okay, so that means coming out of this board, I have a semicircle coming out like this. And the biggest semicircle is right on the y-axis, because that's where you got the biggest gap. You see it.
Yep.
And then the behind the board is the other part of it. So there it is. That's my cross section. It's a disc. These are all the x's. So area of a disc is pi r squared. That's what I'm gonna integrate. That's what I'm gonna integrate, guys. Pi r squared, but in terms of x. All right. Here's the hard part. What is my radius? Well, look. Here's my cross section. Oh, not my cross section. Here's upper minus lower. This is your diameter of that circle, of your section, cross section. So half of that. So here we go. I'm just notice that I'm typing r. R is equal to what's that top curve? So I'm gonna write 2 minus x squared minus what's the bottom curve? Oh, yeah, I should have done it in red here. 2 minus x squared minus x squared. Now that's the diameter. All over 2. That's my radius. Cool or not cool?
Yes.
Okay, so now. Say it again. Oh yeah, you can simplify the numerator. Yeah, I do. I do want to do that. 2 minus 2x squared divided by 2. Oh look, they're making it easy for me. 1 minus x squared. It's not always that simple, but they're making it easy for me. All right, here we go. My a of x. It is from, well, we'll do the limits in a little bit. Pi, parenthesis, 1 minus x squared, close it, squared. Pi r squared. All right. Are we still okay?
Yes.
All right, I need limits. I need to know where these intersect. And yeah. Oh, they tell us? Oh, dang it. Yeah, I'm tired. I didn't even realize what I read. All right, here we go. Integral. -1 to 1. What do I put on the outside of this integrand? Which you can also put it on the inside, but it's better if you just do that. 1 minus x squared, close it, squared dx. This is an example of one that you could be asked to do on your own without a calculator. Yes, you can. You can do it. You have all had algebra 1 and algebra 2, and look, I'm going to put it here on the side. 1 minus x squared squared is easy to do. 1 times 1, 1. 1 times x squared is negative x squared, but you have 2 of them, so minus 2x squared. Negative x squared times negative x squared plus x to the 4th. Do you guys see what we did?
Yes.
Okay, so here we go. Equals pi on the outside, integrand, -1 to 1. And I'm going to write 1 minus 2x squared plus x to the 4th dx equals, and let me write it up here. Antiderivative of 1 is x. Antiderivative of 2x squared is 2x cubed over 3. And antiderivative of x to the 4th is x to the 5th over 5. And -1 to 1. And I'm kind of regretting going from -1 to 1. I kind of wish I would have done 0 to 1 and then just multiplied by 2, but that's fine. Are we still okay? All right. I have my pi on the outside. I'm just going to plug in a 1 and then plug in a -1. I was going to say double it, but whatever. Pi bracket, let's see, 1 minus 2/3 plus 1/5. Oh, they're not making it so easy for me. I'm gonna multiply it by 2. So there, I'm doing a shortcut already. Times that by 2. Can I do that? Because the other one's gonna be the same thing, but negative and then minus negative positive. All right, 1 minus 2/3 is 1/3, and then I'm gonna come over here. 1/3 plus 1/5. Let's see, times 3 over 3 times 5 over 5. 5, 6, 7, 8. 8. So 2 pi times 8 over 15. So if I didn't make any mistakes, I see 16 pi over 15. Let's check if that really is the answer. We trust Avidus. Avidus, you want to check it for us, please? I don't think so. See what 16 pi over 15 is in decimal, and then type in the shortcut. And then just type in this guy, yeah. You got it? Okay. All right, guys. I can't focus this. Don't worry, we're almost done. All right, guys. So hopefully you've done enough problems today that we have the basics down of volumes. Do you feel better with today?
Yes.
All right. On Monday we will do one more volume problem, just to make sure that you guys got the gist of it all, and then we're done with volumes, and then we'll study the next section that we're weak on, based off of the mock exam. It's probably going to take me a while to grade the mock exams. You guys have first priority. Oh, let me stop recording here. You guys have first priority, guys.